Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring real-world problems involving linear inequalities in one variable. Let's look at example 1. Suppose you borrow $255 from your parents to purchase a set of headphones. If you plan to get a summer job earning $14 per hour, what is the minimum number of full hours you must work to earn at least $255? So it's important when you're solving a real-world problem to identify your knowns and your unknowns. Now, I'm going to use a highlighter, but you could circle or underline the information as needed. So I'm going to highlight in pink what I do know about this problem. First of all, I know that I borrowed $255. I also plan to get a summer job earning $14 per hour. And what I don't know is the minimum number of full hours I must work to earn at least $255. Now, we're going to solve this two ways. We're going to first use a table to solve this, and then we're going to use algebra to solve it. So let's start with the table. It says fill in the guess and check table below to help you solve the problem. So in this table, they've given you different number of hours, 20 hours, 19 hours, and 18 hours. They want you to calculate how much you would earn for each of those hours, and then ask yourself, is that amount at least $255? So pause the video and try to fill out this table on your own. All right, welcome back. Let's see how you did. For my calculations, I know that I'm earning $14 per hour. So if I work 20 hours, that would give me a total of $280. So the question is that amount at least $255? Yes. Okay. What if I only work 19 hours? Would I have enough money to pay my parents back? So let's look at that. $14 an hour times 19 hours. Let's see, what would that be? 14 times 19. That would be $266. Is that enough to pay my parents back if I owe them $255? Yes. All right. What if I only work 18 hours? So 14 times 18. Let me change that. Let me delete that 19 and change it to 18. 252. So is that amount at least $255? No. So according to the calculations in the table, what is the minimum number of full hours you must work to earn at least $255? So that would be 19. That was the minimum that you could work to earn at least $255, according to our table calculations. All right, problem C. Write and solve an inequality to determine the minimum number of full hours you must work to earn at least $255. So what this means is that our earnings must be greater than or equal to 255. They've got to be at least 255. So it's greater than or equal to. Now, we need to write an equation. So we need to, write an inequality. So we need to identify our unknowns. So let's let H equal the number of hours you must work. All right. So to write our inequality, we would say 14H must be greater than or equal to 255. Now, this is a simple one-step equation that we can use inverse operations to solve. So The inverse operation for 14 times age is we would divide by 14. So our number of hours must be greater than or equal to 255 divided by 14, which is 18.21. Now, here's an interesting thing that's happening here. Pretty much through your entire math career up to this point, you've always been taught that you would round down because this is 18.2. But in this problem, 18, if we round down to 18, 18 did not satisfy our problem, because if we only work 18 hours, we would not work at least $255. So we remember our hours must be greater than or equal to 18.21. So the next whole number above 18 is 19. So you must work at least, I'm sorry, let's say, the question was, what is the number of full hours you must work? So I'm going to answer it like this. You must work 19 full hours. Okay. So with inequalities, sometimes our rounding rules don't really apply. You have to kind of think about the problem a little bit. All right. Example 2. An empty crate weighs 30 pounds. What is the greatest number of books weighing 1.5 pounds each that can be packed in the crate if the filled crate may weigh no more than 60 pounds? All right, so I'm going to use my highlighter again. I'm going to use pink to highlight what is known and green to highlight what is unknown. So here's what I do know. I know we have an empty book crate that weighs 30 pounds. And then we're going to fill it with books that weigh 1.5 pounds each, okay? And what I don't know is what is the greatest number of books that can be packed in the crate if the filled crate can weigh no more than 60 pounds. So what is unknown? What is unknown is the greatest number of books. So I can let my unknown is let B equal the number of books. Let B equal the number of books that we're going to put in this crate. Okay, that's our unknown. That's what we're trying to find. All right, so what I know here is the weight of the crate plus the weight of the books can be no more than, so less than or equal to, 60 pounds. All right. So in other words, the crate plus the books has to have a weight that's 60 pounds or smaller. So we do know, going back to our pink highlighted information, that the weight of the crate was 30 pounds. And the weight of each book was 1.5. So 1.5b, that must be less than or equal to 60. All right, so we'll solve this inequality by subtracting 30 from each side to get 1.5b is less than or equal to 30, and then divide both sides by 1.5. So our number of books, let's see, 30 divided by 1.5, that would give me 20. So let's be sure we answer the correct question now. What is the greatest number of books? So I could place in here 20, 19 books, 18, 17, and I would be under 60 pounds. But they wanted to know the greatest number of books that we could put in. So the greatest number of books that can be placed into the crate is 20. The greatest number of books that can be placed into the crate is 20. All right, example 3. Kevin's history grade will be determined by the average of 4 tests. He has earned a 76, an 85, and a 74 on the first 3 tests. He needs to get an average of at least 80 to receive a B in the class. Determine the minimum grade he can make on the 4th test to achieve his goal. All right, so let's highlight what we know in pink. We know that his grade will be determined by the average of 4 tests. We also know he earned a 76 and 74 on the first 3 tests. We also know he needs to get an average of at least an 80 to receive a B in the class. Our unknown, determine the minimum grade he can make on the 4th test to achieve his goal. So that's our unknown. So that's how we assign our variable, by identifying our unknown. So I'm going to let G equal his grade on the 4th test. Okay, that's our unknown. All right, now remember, when we're finding an average of anything, we add those things up, no matter how many you have. In this case, we're going to have 4 things, and we divide it by that number. So in this case, you're going to take his test grades. We got 76 on the first test grade, 85 on the second test grade, 74 on the third test grade, and we do not know his 4th test grade. So I'm going to put grade. Grade unknown. We do not know it. However, be careful, because a lot of students think you should divide by 3 here. But notice there are 4 test grades. Even though we don't know what one of them is, we know we're going to have a 4th test grade. So be sure to divide by 4. That's the most common mistake I see students make on this problem. They try to divide it by 3 instead of 4. Okay, now I want my grade to be at least an 80. So it can be 80 or higher, 80, 81, 82, 83, 84. So I want to make sure I'm greater than or equal to 80. All right, now remember, when we're solving problems with fractions like this, we want to get rid of the fraction first by multiplying both sides by the denominator. So in this case, our denominator is 4. So I'll multiply this side by 4 and multiply this side by 4. So when I do that, this 4 will cancel with this 4, and I'm left with 76 plus 85 plus 74 plus G is greater than or equal to 320. Now, if I add up my like terms, I would have 76 plus 85 plus 74. That would give me 235 plus G is greater than or equal to 320. Now subtract 235 from both sides. So the grade must be greater than or equal to, let's see, 320 minus 235 gives me 85. So he could make, if he wants the grade in the class to be at least an 80, on his 4th test he could make an 85, 86, 87, on and on and on, okay? Anything above 85, okay? As long as he makes above an 85 on the test, he'll have a B in the class. So the question said determine the minimum grade. So in this case, our minimum grade, let me highlight in yellow, he needs is an 85. So Kevin needs to make at least an 85 on his fourth test. All right, example 4. Mrs. Garza wants to have a clown deliver balloons to her daughter. Clowns Are Fun charges $1.25 per balloon plus $6 for delivery. Singing Balloons charges $1.95 per balloon for $2 for delivery. What is the minimum number of balloons Mrs. Garza needs to purchase for Clowns Are Fun to have a lower price than singing balloons? So let's highlight in pink what we do know. We do know that Clowns Are Fun charges $1.25 per balloon plus $6 for delivery. Singing Balloons charges $1.95 per balloon plus $2 for delivery. What is unknown? We do not know the minimum number of balloons Mrs. Garza needs to purchase to have a lower price for Clowns Are Fun to have a lower price than singing balloons. Okay, so our unknown is the minimum number of balloons. So let's let B equal the number of balloons. Let B equal the number of balloons. Now, we want the Clowns Are Fun to be less than, because we want it to have a lower price than singing balloons. Okay, Clowns Are Fun must be lower because we want it to have a lower price than singing balloons. So let's talk about what Clowns Are Fun charges. Clowns Are Fun charges $1.25 per balloon plus $6. Singing Balloons charges $1.95 per balloon plus $2. So now we'll just solve this equation. Now we have variables on both sides. So the first thing I want to do is move all the variables to the left. So 1.25 minus 1.95. So that would be negative 0.7b plus 6 is less than 2. Now subtract the 6 from both sides. So negative 0.7b is less than negative 4. Now divide both sides by negative 0.7. Now remember, when you're solving an inequality, if you divide by a negative, you must reverse your symbol. So b would be greater than, we want to take negative 4 and divide it by negative 0.7, and that gives me 5.71. So we want the minimum number of balloons. So 5 balloons is not enough. So she could purchase 6, 7, 8, 9, and on and on and on. So the minimum number of balloons would be 6. So Mrs. Garza must purchase 6 balloons. All right, example 5. At Jacob's new job, he earns a base salary of $400 per week plus 5% commission on all of his sales. If Jacob wants to make at least $600 every week, how much will he need in sales? All right. So in pink, let's highlight what we know. We know he earns a base salary of $400 per week plus 5% commission on all his sales. We also know he wants to make at least $600 every week. What we don't know is how much will he need in sales. So that's our unknown. So I'm going to let X equal the amount of sales. All right, I'd like you to pause this video and try this problem on your own. But before you do, let me give you one hint. You want to use the decimal equivalent of 5% when you write your inequality, which is 0.05. So pause this video and try this problem on your own. All right, welcome back. All right, what I did is I wrote an inequality and I said that Jacob will earn $400 plus 0.05 times his amount of sales. And I know he wants to make at least $600, so greater than or equal to 600. So that's my inequality. Then I solved it by subtracting 400 from both sides. So that gives me 0.05x is greater than or equal to 200. And then I divided by 0.05. So 200 divided by 0.05, $4,000. So he must have at least $4,000 in sales. If necessary, pause the video and correct anything that you might have got wrong. And that concludes today's lesson, solving real-world problems involving linear inequalities.